When Germany signed its surrender in 1918, no one imagined that from the ruins of that defeated empire, one of the darkest ideologies in modern history would be born. Humiliated, impoverished, and divided, the German nation became fertile ground for a movement that promised redemption but brought destruction. The Nazi regime did not emerge from nothing. It was the result of unhealed wounds, collective fears, and a political machine that transformed despair into hatred. This is the story of how a cultured, modern, and wounded nation surrendered to the totalitarian delirium that would forever change the fate of the world. Sonnengewehr, or the solar cannon, Hitler's visionary and terrible technological fantasy. During the final years of World War II, scientists in the Third Reich worked on projects that defied logic and bordered on science fiction. Among the most ambitious and bizarre was the Sonnengewehr, popularly known as the Sun Cannon. The idea behind this project was as audacious as it was terrifying: to build a gigantic space station equipped with a parabolic mirror capable of concentrating the sun's rays and directing them toward Earth, with the theoretical capacity to set entire cities ablaze or melt steel structures from orbit. It was a concept that, while fantastical, reflected the regime's obsession with total control and technological supremacy. The Sonnengewehr project was initially inspired by Hermann Oberth, one of the pioneers of German astronautics, who in 1929 raised the possibility of a mirror several kilometers in diameter capable of reflecting sunlight towards specific targets on Earth. Decades later, under the Nazi regime, this theoretical proposal was revived by military engineers and scientists as an idea for a strategic weapon that could alter the balance of global power. Preliminary calculations for the project estimated that a mirror located more than 8,000 kilometers above the Earth could generate temperatures capable of melting metals or causing massive fires, transforming sunlight into an instrument of near absolute destruction. The Sonnengewehr, or solar cannon, is perhaps one of the most emblematic examples of the extent to which technological obsession and delusions of grandeur could go in Nazi Germany. Although it was never built, the studies that were carried out reveal a combination of scientific ambition and ideological fanaticism that is difficult to imagine. The reports recovered by the Allies detailed extremely complex calculations about the orbital stability of a mirror several kilometers in diameter, its resistance to mechanical and thermal stresses, and the type of materials needed to reflect and concentrate sunlight with enough intensity to melt metal or set entire cities on fire. This level of detail reveals that, beyond a simple megalomaniacal dream, there was a conscious effort to understand the limits of physics and engineering, albeit applied to impossible war purposes. The Nazi regime even planned mirror control and orientation systems to precisely target specific objectives on Earth. Adjustment, stabilization, and cooling mechanisms were studied, as well as methods for launching the mirror into orbit using high-powered rockets, which implied an advanced understanding of astronautics for the time. The idea of maintaining a structure several kilometers in diameter in space was not only technically unfeasible with the technology of the 1940s, but also required resources and materials that Germany could not provide in the midst of a conflict that consumed all its productive and logistical capacities. Even so, the mere existence of these plans and calculations reflects the mentality of the Third Reich in its final years. Despair and defeat did not stop the fantasy of weapons capable of changing the course of the war. The Sonnengewehr symbolized an attempt to project German power beyond Earth, to turn technological supremacy into an instrument of absolute terror. The scientists involved, under political pressure and with the constant specter of execution for failure, explored ideas that combined extreme innovation with a total disregard for practical feasibility. Beyond its impossibility, the Sonnengewehr left a symbolic legacy. It represents the intersection between science, unbridled ambition, and ideological fanaticism. Although it never actually existed, its conception illustrates the Third Reich's will to pursue an almost divine power, a desire for absolute control that ignored any ethical, economic, or technical limits. Today, the documents and studies of this project serve as a historical warning about how science, when subordinated to fanaticism and megalomania, can imagine unimaginable horrors, leaving behind a testament to uncontrolled ambition and dreams of domination that could never materialize. The circular plane, or Nazi flying saucer, the aeronautical mystery of the Third Reich. Among the most unusual and fascinating projects of Nazi Germany was the so-called Circle aircraft, also known as the Nazi flying saucer. This development represented a completely revolutionary approach within military aviation, a disc-shaped aircraft designed to reach extraordinary speeds, perform maneuvers impossible for any conventional aircraft of the time, and potentially change the air strategy of the conflict. The idea defied the logic of traditional aerodynamics, combining futuristic aspirations with the military ambition characteristic of the Third Reich. The design of this aircraft is attributed to a group of secret engineers, among whom was Hanno Reich, a renowned test pilot and advisor on experimental flight programs. The craft was designed for vertical takeoff and landing, eliminating reliance on long and vulnerable runways, and its circular structure gave it superior theoretical stability against wind and aerodynamic drag. Some documents and testimonies suggest that the project also contemplated the installation of experimental weaponry, high-powered cannons, advanced propulsion systems, and even attack mechanisms that could have changed the course of air combat, although always within a more speculative than practical framework. During the war, only small-scale prototypes and mock-ups were built, and some limited flight tests were carried out, mainly to study the stability of the design and its viability. However, the models were never completed or put into production, partly due to enormous technical difficulties, shortages of materials, and constant pressure from the military fronts. After the fall of the Third Reich, the plans, reports, and prototypes found by the Allied forces sparked a lasting fascination, fueling rumors and theories about secret experiments in advanced engineering and, over time, contributing to the myth of Nazi flying saucers that has so intrigued historians and tech conspiracy enthusiasts. Beyond the legends, this project reflects the Nazi regime's obsession with technological supremacy and the development of weapons that were not only effective, but spectacular and disruptive. The circular airplane symbolizes the combination of fanaticism, desperation, and creativity applied to war purposes, an example of how the most advanced engineering was used to pursue ideas that bordered on science fiction. Although it never became operational, the mere conception of the project demonstrates the extent to which the Third Reich was willing to push the limits of technology in its attempt to overcome its enemies and perpetuate its vision of total domination. The Gustav Canyon, the monstrous engineering project of the Third Reich. Among the most impressive and colossal military inventions of Nazi Germany, the Gustav Cannon, officially known as Schwerer Gustav, occupies a unique place. Conceived in the 1930s by the Krupp Company, this railway gun was an extreme example of the Third Reich's technological and propaganda approach to create weapons that were not only effective but also intimidating and awe-inspiring. Its original objective was to overcome the toughest fortifications of the time, especially the Maginot Line in France, considered virtually impregnable by conventional artillery. With a colossal caliber of 800 millimeters, the Gustav could fire projectiles weighing up to 7 tons at distances of almost 47 kilometers, a feat that transformed each launch into a spectacle of military engineering. The complexity of its operation was equally extraordinary. It required a crew of more than 1,400 men, along with engineers, technicians, and logistics specialists, plus a 25-car train just to transport it and store ammunition. The assembly of each shot could take several days, and every movement of the cannon had to be meticulously planned to prevent the magnitude of its size from becoming a weakness against enemy attacks. The Gustav cannon, or Schwerer Gustav, was not only a colossal work of engineering but also a symbol of the extremist mentality of the Third Reich, where size and power were confused with technological and military supremacy. Its development began in 1937, when the Krupp Company was commissioned to build a weapon capable of overcoming the strongest defenses of the Maginot Line and any fortification that France might present in case of conflict. The magnitude of the project was such that it involved not only highly specialized engineers and technicians, but also a colossal logistical network. More than 1,400 soldiers for its transport and assembly, special 25-car trains, giant cranes, and meticulous planning for every movement. During the siege of Sevastopol, the Gustav demonstrated its devastating firepower. Its 7-ton shells could penetrate up to 7 meters of reinforced concrete, leveling bunkers, artillery batteries, and fortifications that had withstood conventional attacks for years. However, this show of force came at a high cost. Each shot required hours of preparation, and the Gustav's vulnerability to Allied air attacks was evident. The need to protect it with dozens of tanks, anti-aircraft artillery, and specialized personnel made it a valuable and extremely slow strategic target, unable to respond to rapid changes on the front. In addition to its military role, the Gustav had a considerable psychological effect. Its mere presence intimidated both enemy soldiers and allies, reinforcing the idea that Germany was prepared to take the war to unprecedented extremes. Allied reports from the time describe how the civilian population and the opposing armies perceived the Gustav as a steel monster capable of making any defense disappear, becoming a living myth even among those who never saw it in direct action. In the long term, the Gustav cannon became an example of the unbridled ambition of the Third Reich, a machine that showed how far German engineers could go under the pressure of a regime obsessed with technical perfection and military supremacy. Although its practical utility was limited and its deployment costly and vulnerable, the Gustav remains as a historical testament to the combination of extreme ingenuity, fanaticism, and war spectacle that characterized the boldest and at the same time most irrational projects of Nazi Germany, reminding us how the pursuit of absolute power can lead to constructions that are both masterpieces of engineering and monuments to obsession and military extravagance. The invisible plane Ho 229, the air weapon that was decades ahead of its time. Among the most visionary and daring inventions of Nazi Germany is the Horten Ho 229, a fighter-bomber aircraft that broke with all the canons of aviation of its time. Conceived by the Horten brothers, Walter and Reimar, this flying wing design lacked a traditional tail and fuselage, integrating all its structures into a single aerodynamic shape. This configuration not only drastically reduced air resistance, but also allowed speeds higher than most Allied fighters and maneuverability that defied the standards of the 1940s. It was a device conceived not only for war, but as an extreme example of futuristic engineering applied to military aeronautics. The Ho 229 also stood out for its pioneering approach to reducing radar signature, a revolutionary concept for the time. Engineers explored composite materials and coating techniques with layers of wood and resin, designed to absorb electromagnetic waves and make detection by enemy radar more difficult. This feature makes it one of the first documented attempts to create a stealth aircraft, decades before modern stealth technology was developed in the United States. The combination of aerodynamic design and experimentation with innovative materials reflects the obsession of Nazi scientists to push technological limits even in the midst of war. Although it never entered mass production or saw combat, several prototypes of the Ho 229 were built and tested in northern Germany. These tests demonstrated its speed and stability, but also revealed the technical challenges imposed by such a radical design. Control, materials, and propulsion problems limited its practical viability. Even so, the project served as a laboratory of ideas that anticipated aeronautical solutions that decades later would be fundamental to modern aviation. The Horten Ho 229 was not simply an aircraft, but the materialization of a radical technological vision that combined advanced aerodynamics, materials engineering, and futuristic warfare strategies. Its flying wing design eliminated the conventional tail and fuselage, significantly reducing air resistance and allowing speeds and maneuverability superior to any fighter of the time. This concept, devised by the Horten brothers and perfected by engineers from the jet aircraft program, sought to give the Luftwaffe a strategic advantage that could change the dynamics of air combat in Europe. In addition to its innovative design, the Ho 229 incorporated experimental features that we can now recognize as precursors to stealth technology. Engineers worked on wood and resin coatings with the intention of reducing radar reflection, seeking to make the aircraft virtually undetectable to Allied detection systems. Although the technical means of the time prevented achieving total invisibility, these tests laid the foundations for what decades later would become modern stealth aviation. The combination of speed, maneuverability, and stealth made it a project that, had it been mass-produced, could have posed a considerable technological challenge to the Allies. The Ho 229 also reflects the context of desperation and extreme ambition of the Third Reich in its final war years. Mass production of conventional aircraft was limited by resource shortages and the pressure of Allied bombing raids, so the Nazis focused on advanced projects that could deliver decisive results, even if they were technically risky or incomplete. In this sense, the Horten Ho 229 embodies the balance between scientific audacity and strategic delusion, an apparatus that represented both the genius of its creators and the obsession of a regime that sought to win the war at all costs through technological superiority. Today, the few prototypes that survived the war are preserved as tangible testimonies of an era in which German engineering reached extraordinary levels of sophistication and risk. The Ho 229 is remembered not only as an advanced fighter jet, but as a symbol of the potential of science when mixed with extreme ambition and ideology, a historical warning about how technology can be used for both innovation and war. It represents the pinnacle of creativity and technological delirium of the Third Reich, and its legacy continues to inspire studies on aeronautical design, aerodynamics, and stealth systems even decades after its conception. Dwarf subs, small machines, great hopes in the twilight of the Reich. During World War II, Nazi Germany did not limit itself to building the legendary large U-boats. It also invested considerable effort in developing Midget submarines, designed to carry out special missions that conventional submarines could not perform. These small submersibles, designed for espionage, sabotage, and surgical strikes on enemy ports or protected coastal areas, were truly pioneers in terms of stealth and maneuverability. Their small size allowed operators to approach strategic targets almost imperceptibly, place explosive charges or light torpedoes, and withdraw before enemy defenses could react, a tactic that made these vehicles precision weapons rather than instruments of mass combat. Among the best-known models were the Marder, the Biber, and the Seehund, each with particular characteristics adapted to different types of missions. The Marder, for example, could be crewed by a single man and was designed to attack vessels in ports and canals. The Biber, also small in size, had the capacity to carry significant explosive loads, while the Seehund offered greater autonomy and resistance for coastal travel. The compact dimensions of these submarines required their crews to work in extremely claustrophobic conditions, facing a lack of ventilation, the risk of exhaust gas poisoning, and the psychological pressure of knowing that any mistake could be fatal. Each mission involved not only technical skill, but also extraordinary courage on the part of the operators, who often found themselves in situations close to suicide. The development of these submarines reflects the technological creativity and obsession of the Third Reich to find ingenious solutions in the face of the growing military pressure from the Allies. Nazi engineers experimented with new electric and mechanical propulsion systems, buoyancy tests, and clandestine navigation methods to ensure that these small submarines could accurately accomplish their objectives without being detected. Although production was limited and losses were high, these vehicles demonstrated the German ability to design specialized weapons that responded to very specific tactical needs, showing a focus on precision warfare and extreme innovation. Despite their limited tactical impact, Nazi Midget submarines represent a fascinating and extreme chapter of military engineering during World War II. Its development arose from the need to carry out special sabotage and reconnaissance operations in areas where traditional U-boats could not operate, such as fortified ports, narrow channels, or coasts guarded by anti-ship defenses. Models like the Marder and the Biber were designed to be operated by one or two crew members with silent propulsion systems that allowed them to approach targets undetected. The idea of using such small vessels for high-risk missions demonstrates the extent to which Nazi engineers were willing to explore extreme and unconventional solutions to maintain a technological advantage over the Allies. The development of these submarines involved considerable challenges. Space limitations forced designers to combine maneuverability, cargo capacity, and structural strength in a tiny hull, while maintaining minimum safety for the crew. The scarcity of materials and the urgency of the war added pressure, but also spurred technical creativity. Each mission was extremely dangerous. The fragility of the hull, the possibility of malfunction of the propulsion system, and the vulnerability to enemy defenses made these vessels almost suicidal instruments. Even so, its use reflects how the Third Reich sought to maximize any technological advantage, even at the cost of extreme human risk. Midget submarines also left an important mark on the subsequent development of military vehicles and unmanned warfare technologies. His concept of small, highly specialized units influenced the design of modern mini-submarines, aquatic drones, and naval infiltration vehicles. Furthermore, they show how the combination of extreme innovation and strategic desperation can lead to ideas that, although impractical in their time, pave the way for unprecedented technological solutions in the future. The engineering behind these vessels demonstrates a meticulous and creative approach where every detail was carefully thought out to accomplish a nearly impossible mission under real combat conditions. Today, midget submarines are remembered not only as military curiosities but as symbols of the Nazi obsession with developing technology that challenged the limits of conventional warfare. They represent the mixture of ingenuity, audacity, and fanaticism that characterized German military research during World War II, showing how the search for technological superiority sometimes led to conceptions that bordered on science fiction. His legacy endures as an example of extreme creativity in times of conflict, a testament to how far engineering can go when combined with the urgency, ambition, and desperation of a nation at war. The Panzer Maus, the largest and heaviest tank in history. The Panzer Maus represents one of the most ambitious and extravagant projects of Nazi military engineering during World War II. Conceived by Ferdinand Porsche starting in 1942, this tracked colossus was designed to be the largest and heaviest tank ever built, weighing over 180 tons, which made it virtually impenetrable to standard Allied artillery. Hitler and the Nazi engineers intended to create a weapon capable of breaking through any defensive line, penetrating fortifications, and dominating the battlefield through sheer firepower and armor, a symbol of the superweapon dream that characterized the final years of the Reich. The Maus had exceptional armor, up to 220 mm on the turret and 200 mm on the chassis, designed to withstand large-caliber projectiles and almost any impact from the artillery of the time. Its main armament consisted of a 128 mm cannon, complemented by a secondary 75 mm cannon, capable of destroying both enemy fortifications and armored vehicles. However, its colossal size and weight made it an extremely slow vehicle with a top road speed of only 20 km per hour, which severely limited its maneuverability and made it vulnerable to air attacks and natural obstacles. Furthermore, crossing rivers or difficult terrain required reinforced bridges, while their transport depended on special locomotives and suitable railway tracks. Throughout the entire war, only 2 Maus prototypes were completed, neither of which saw combat. The logistical problems were enormous. Daily maintenance was complex, fuel consumption was astronomical, and the production of these supertanks was disproportionate to the actual needs on the front lines. Despite its lack of practical use, the construction of the Maus reflects the Nazi obsession with ultimate weapons, an attempt to create war machines that would surpass any known technical limits, even though in many cases their viability in combat was practically nil. Beyond its military dimension, Maus symbolizes the combination of ingenuity and technological delirium that characterized Nazi Germany. It represents the Third Reich's fascination with excess, grandeur, and mechanical superiority, but it also reveals the disconnect between ideological ambition and the practical reality of conflict. Today, the 2 prototypes preserved in museums in Germany and Russia are not only examples of monumental engineering, but also reminders of how the obsession with creating superweapons could overflow any logical limits, turning innovation into a useless luxury amid the Reich's wartime desperation. The VIII cannon, the secret weapon that tried to reach London from France. The VIII cannon, also known as the multiple charge cannon or Hochdruckpumpe, high-pressure pump, is one of the most extravagant examples of the Nazi obsession with superweapons during World War II. Conceived as an instrument of strategic terror, its main objective was to bomb London from continental Europe without relying on aircraft or missiles, extending the Reich's influence through large-scale intimidation. The idea behind the V3 arose from a combination of advances in long-range artillery and Hitler's ambition to create weapons that could change the course of the war through fear and technological superiority. The design of the V3 was astonishingly bold, a cannon over 130 meters long with multiple secondary propellant charges distributed along the length of the tube. Each of these charges had to be ignited in sequence to progressively increase the speed of the projectile, allowing it to travel distances greater than 165 kilometers, something completely beyond the reach of conventional artillery of the time. The engineers had to face enormous technical challenges. The pressure and heat generated in each shot were extreme, the projectiles had to withstand colossal stresses, and controlling the ignition of the secondary charges required a precision that bordered on the impossible with the technology available at that time. The most well-known V3 installation was located in Mimoyec, France, an underground complex excavated in the hills of the Calais region. The construction was monumental, tunnels over 150 meters deep, reinforced concrete fortifications, and internal transport systems to handle projectiles weighing over 1 ton each. However, the effectiveness of the project was limited by constant attacks from Allied aircraft, which destroyed much of the infrastructure before the weapon could operate at full capacity. Only a few test shots were conducted, and the results showed that although technically impressive, the operational practice of the V3 was extremely complicated and vulnerable. Beyond its limited military effectiveness, the V3 symbolizes the unbridled ambition of the Nazi regime and its focus on extreme technology as a means of imposing psychological terror. It was a project that combined advanced engineering, extreme risk, and enormous economic and human resources into something that could never alter the course of the war. Today, the remains of the Mimoyec tunnels, along with the plans and documents found after the liberation, bear witness to the technical capability and ideological obsession of the Third Reich, an attempt to transform science and engineering into instruments of mass destruction and absolute fear, even at the cost of practical and strategic viability. The Cannon V2, the secret weapon that changed war and science forever. The V2 rockets, officially designated Aggregate 4, A4, represented one of the most advanced and terrifying technological developments of Nazi Germany during World War II. Conceived by Wernher von Braun and his team at the Peenemünde Research Center, these rockets were the first ballistic weapon capable of reaching unprecedented speeds and altitudes. They could exceed 5,800 kilometers per hour and reach heights of up to 189 kilometers, thus crossing the boundary of the Earth's atmosphere and entering what could be considered suborbital space. This capability made them not only a tool of destruction, but a weapon of psychological terror, as the attacks were unpredictable and virtually undetectable until impact. Each V2 was approximately 14 meters long, with a diameter of 1.65 meters and was powered by a liquid fuel engine which used a mixture of alcohol and liquid oxygen. Its explosive payload weighed about a ton, allowing it to cause massive destruction in urban areas. The aerodynamic design, gyroscopic stabilization systems, and rudimentary electronic guidance were concepts ahead of their time and laid the foundation for later space exploration. The production of the V2 was a massive and brutal process. Thousands of forced laborers, mostly prisoners from camps like Dora Mittelbau, were forced to assemble the rockets under extreme conditions with a very high mortality rate due to exploitation, hunger, and accidents. The strategic bombings were mainly directed against London, Antwerp, and Liège, causing tens of thousands of civilian deaths and leaving considerable devastation to the infrastructure. Despite their technological sophistication, the V2s could not alter the course of the war. Their production was expensive, slow, and required resources that could have been allocated to other, more decisive fronts. However, its impact was profound in terms of war psychology. The attacks were inevitable and impossible to intercept with the defensive technology of the time, generating constant terror in the civilian population. After the war, the V2 became the foundation of space programs both in the United States, with the NASA rocket program led by von Braun, and in the Soviet Union, which captured German technology and personnel to develop its own rocketry. In retrospect, These rockets represent a paradigmatic example of how technical innovation can be used for both destruction and space exploration, and how scientific ambition can coexist with the most cruel human exploitation. The V2s are a historical reminder of the double-edged sword of technology. The same engineering that enabled advances to the moon and beyond emerged from suffering, war, and a regime's obsession with absolute power. The Reichenberg 4 suicide plane, the mission of no return from the Nazi sky. The Reichenberg 4 is one of the most extreme and emblematic projects of the Third Reich's technological desperation. This manned suicide attack aircraft emerged as a direct evolution of the Fieseler Phi-103, better known as the V-1 missile, adapted to be guided by a human pilot with the aim of striking strategic targets with maximum precision. The design of the Reichenberg 4 reflects not only the search for radical military solutions, but also the combination of ideological fanaticism and military urgency that characterized the final years of the war, when Germany was on the brink of defeat and the need for miracle weapons became an obsession. The design was simple but lethal: a compact fuselage, minimal cockpit, basic controls, and a propulsion system similar to that of the V-1 rockets. The pilot had to handle the aircraft during takeoff, flight, and final approach, aware that the probability of survival was virtually zero. This suicide mission was conceived as the ultimate expression of individual sacrifice for the cause of the Reich. To train the pilots, known as Leonidas, test flights were carried out with unarmed versions and with progressive modifications, testing their ability to control the aircraft under extreme conditions and at dizzying speeds. Although several prototypes were built and flight tests were conducted, the Reichenberg 4 never saw actual combat. Technical limitations, such as the fragility of the materials, instability at high speeds, and the risk of accidents during takeoff and flight, combined with resource scarcity and the rapidly approaching end of the war, prevented the Luftwaffe from effectively deploying this project. However, its development demonstrates the Nazi regime's willingness to sacrifice human lives in the name of military efficiency and the cult of extreme heroism, turning desperation into a driving force for perverse technological innovation. The legacy of the Reichenberg 4 transcends its operational failure. It symbolizes Nazi Germany's obsession with total war, extreme engineering, and radical weapons. It was a project that fused technical audacity with ideological fanaticism, a clear example of how far human creativity could go when it was subordinated to horror and ideology. Today, the documents, models, and testimonies about this aircraft serve as a reminder of the human and moral cost of unbridled ambition, and as a historical warning about the ethical limits that are broken when war and despair prevail over humanity. The flying tank, the impossible dream of the Luftwaffe. The flying tank represents one of the most extraordinary and at the same time surreal projects of Nazi Germany during World War II. The idea behind this invention was to merge the power of a tank with the ability to fly, a concept that sought to provide unprecedented strategic mobility, a vehicle capable of overcoming natural obstacles and enemy defenses, landing directly on enemy lines and delivering its devastating weaponry where traditional tanks could not reach. This obsession with creating weapons that would break the limits of warfare reflects the mentality of the Third Reich in the final years of the conflict, where desperation and technological ambition were mixed with ideological fanaticism. The conceptual design was extremely ambitious, a heavy tank equipped with large propellers and retractable wings, intended to take off from special platforms or improvised airfields. Its objective was to carry out surprise attacks from the air, combining the firepower of an armored vehicle with the maneuverability of an aircraft. However, the engineering required for a project of such magnitude presented almost insurmountable problems. The weight of the armor, which had to protect both the vehicle and its crew, combined with the limited power of the engines available at the time, made controlling the vehicle in the air extremely difficult. Furthermore, the landing and stabilization systems were unprecedented and posed a very high risk of accidents during testing. Despite detailed plans and some small-scale prototypes, the flying tank was never built into an operational version, nor did it undergo any significant test flights. Resource scarcity, the pressure of the battlefronts, and the priority given to more advanced and feasible projects such as the VIII rockets, the Me-262 jet aircraft, and the Ho-229 relegated this idea to the status of an experimental concept. However, the engineers' persistence in exploring the aerial mobility of tanks and armoured vehicles reflects the Nazis' willingness to overcome practical reality through technical audacity, although often bordering on fantasy. The flying tank, though never built, leaves a historical legacy as a symbol of the extreme approach to Nazi military engineering, a hybrid of innovation, fanaticism, and desperation. It represents the obsession with creating superweapons capable of changing the course of the war, even if they were impossible to build. Furthermore, their study allows us to understand the extent to which Nazi Germany was willing to sacrifice resources, time, and human lives in pursuit of ideas that defied physics, logic, and military practice. Today, the plans and sketches of the flying tank are preserved as a testament to the ingenuity and technological madness of a regime that, on the verge of collapse, dreamed of defying the laws of war and aerodynamics, leaving behind a fascinating and terrifying historical record. The rocket submarine, war from the depths of the Atlantic. The rocket submarine represents one of the boldest and strangest experiments of Nazi Germany during World War II, an attempt to merge submarine technology with advanced rocket propulsion. The idea arose from the need to create a weapon capable of combining the surprise and stealth of submarines with the speed and devastating impact of rockets, a hybrid that would allow for rapid attacks on coastal or naval targets without giving Allied defense systems time to react. This obsession with creating impossible weapons systems reflects the mindset of Nazi engineers in the final years of the conflict, when desperation and the urgency for a technological advantage became the driving forces behind the most extreme innovation. The rocket submarine design envisioned a relatively small submersible equipped with liquid-fueled rocket engines capable of propelling the vessel to high speed once it surfaced. In theory, this would allow the vehicle to stealthily approach the enemy coast, surface suddenly, and attack with projectiles or explosive charges before the defenses could respond. However, the technical challenges were colossal: the stability of the submarine at high speeds, the pressure exerted on the hull by the rocket propulsion, the need for precise steering systems, and the shortage of suitable materials for the engines made any actual operation extremely dangerous and risky for the crew. Although some prototypes were built and limited testing was carried out, the project never progressed beyond the experimental phase. The complexity of the design, the lack of resources, and the urgency of the war led the Nazis to prioritize more feasible technologies, such as conventional U-boats, guided torpedoes, and V-2 rockets. However, documents and sketches recovered after the war show the extent to which the engineers of the Third Reich were willing to defy practical logic to achieve strategic advantages through the most advanced technology, even if it was purely theoretical. Today, the rocket submarine is remembered as an example of the audacity, ambition, and technological delirium of Nazi Germany. It represents the pursuit of weapons capable of merging different domains, sea, air, and land, into a single attack system, demonstrating how fanaticism, desperation, and advanced engineering combined to give rise to projects that bordered on science fiction. Although it never saw combat, this invention leaves a fascinating historical legacy, a testament to the extreme ingenuity and obsession with technological superiority that characterized the final years of the Third Reich, and a reminder of how far military imagination can go when mixed with the urgency of war and ideology. The sonic cannon, the invisible weapon that destroyed with sound. The sonic cannon was one of the most peculiar and ambitious projects developed by Nazi Germany during World War II, an attempt to use the physical properties of sound as a weapon of war. The idea arose in the context of a regime obsessed with any technological advantage that could tip the scales in its favor, even if it meant experimenting with concepts that seemed to border on science fiction. Nazi scientists were fascinated by the potential of high-frequency sound waves and their ability to affect both human beings and physical structures, and the sonic cannon became a symbol of that technological audacity and the desperation of the final years of the conflict. The sonic cannon's design was as innovative as it was complex. It consisted of enormous resonant tubes and large speakers capable of generating low and high-frequency waves with extraordinary intensities. Engineers expected that these vibrations could cause dizziness, disorientation, physical pain, and even damage to internal organs in exposed individuals, as well as destabilizing buildings, bridges, and light vehicles. It was estimated that, in theory, the energy concentrated in these waves could knock down fortification walls and cause chaos in enemy lines without the need for conventional ammunition. However, the technical challenges were monumental, maintaining wave coherence, directing it to a specific target, and generating sufficient power with the available equipment exceeded the technological capabilities of the time. Experiments with the sonic cannon were conducted in a limited way, mainly in laboratories and controlled testing areas, but never reached an operational level that could be applied in real combat. The prototypes showed that, although the concept was theoretically viable, energy losses, wave dispersion, and material limitations made the weapon impractical. Despite these difficulties, the project continued to advance experimentally, fueling the regime's obsession with creating superweapons that could reverse the impending defeat and sow terror among enemies. Beyond its functionality, the sonic cannon reflects the mindset of Nazi engineering, a combination of ingenuity, audacity, and fanaticism, where creativity was mixed with desperation and ideology. This project shows the extent to which the scientists and military of the Third Reich were willing to explore uncharted territories, crossing the line between science and fantasy, always hoping to achieve an unmatched strategic advantage. Although it never progressed beyond the experimental stage, the sonic cannon stands as a testament to extreme innovation and an obsession with total war, leaving a historical legacy that demonstrates how the pursuit of technological power can lead to the development of weapons that seem straight out of a science fiction novel, but were conceived with the most real and terrifying intention possible: to change the course of war through radical and extremely dangerous ideas. The Schwimmwagen amphibious tank, the all-terrain machine of the German army. The Schwimmwagen was one of the most ingenious developments in the German arsenal during World War II, an amphibious vehicle that combined land and water mobility in a way that was surprisingly efficient for the time. Its creation responded to a specific strategic need: to allow troops to move freely across flooded areas, fast-flowing rivers, swamps, or muddy terrain, where conventional transport and infrastructure such as bridges were limited or non-existent. This capability gave German units a significant advantage in rapid maneuvers, flanking maneuvers, and emergency evacuations, demonstrating the Third Reich's focus on logistics and versatility on the battlefield. On land, the Schwimmwagen functioned as a lightweight off-road vehicle, equipped with four-wheel drive and reinforced suspension, capable of traversing rough terrain, mud, rocks, and steep inclines. The transition to aquatic mode was equally innovative. When activated, a rear propeller driven by the engine allowed for relatively fast and controlled navigation on rivers, lakes, or coastlines. This combination of land and sea capabilities meant that units equipped with the Schwimmwagen could operate autonomously, without relying on engineers to build bridges or trailers to transport heavy vehicles across waterways. The vehicle was designed with practicality and basic occupant safety in mind. While it lacked heavy armor and firepower comparable to tanks or cannons, it offered light protection against shrapnel and small-caliber projectiles, as well as enough space to transport 4 soldiers with their equipment and supplies. Its compact size and low weight made it more maneuverable and difficult to detect from a distance, which was especially useful for reconnaissance, patrol, or rapid incursions into enemy territory. Thousands of units were produced during the war, and its use spread across all fronts where the Wehrmacht and Waffen-SS operated, from east to west, including North Africa and the Balkans. Beyond its functionality, the Schwimmwagen reflects the German engineering mindset applied to warfare, combining creativity, efficiency, and adaptability to create practical solutions to complex logistical problems. Its development not only demonstrates the technical prowess of the Third Reich's engineers, but also their obsession with inventions that offered extreme tactical advantages, even if they weren't direct combat weapons. Today, the Schwimmwagen is considered a symbol of military innovation, a testament to how German engineering during World War II sought to overcome the conventional limits of mobility and versatility on the battlefield. and a reminder of how technology could transform strategic operations without always resorting to brute force. The Telegued dogs, or the Goliath Trägerfahrzeug. The Goliath Trägerfahrzeug represented one of the most unique and visionary developments in German military engineering during World War II. This small, remotely operated vehicle, known as a mini-tank, was designed to penetrate minefields, destroy enemy fortifications, and attack armored vehicles without exposing soldiers to direct danger. Its conception arose from the need to minimize human casualties in extremely risky operations, demonstrating the combination of innovation and extreme pragmatism that characterized many Nazi projects in the final years of the conflict. The Goliath was compact, allowing it to be easily transported by truck or even carried manually when necessary. It was equipped with a remote control system connected by a cable up to 650 meters long, enabling the vehicle to be guided to its target with relative precision. This technology, advanced for its time, reflected the Third Reich's fascination with experimenting with futuristic concepts, even amidst resource scarcity and the constant pressure of the battlefronts. Some reports suggest that during testing, operators had to maneuver carefully to avoid obstacles, control speed, and ensure the Goliath hit enemy structures or vehicles accurately. Different models were developed, adapted to varying terrain conditions. Some wheeled, others tracked, each loaded with explosives ranging from 60 to 100 kilograms. The payload was sufficient to destroy light vehicles, small bridges, bunkers, and other defensive structures. However, the Goliath's effectiveness was limited by several factors. Its extremely slow speed made it vulnerable to gunfire, obstacles, and uneven terrain, and the fragility of its armor meant that any impact could neutralize it before it reached its target. Despite these drawbacks, the units that did manage to reach their destination performed their function devastatingly, demonstrating the concept's potential, albeit situationally rather than on a large scale. The Goliath Trägerfahrzeug can be considered a precursor to modern military drone and explosive robot technology. Its design and execution, though limited in practice, reflected the audacity of Nazi engineers to experiment with autonomous and remotely controlled vehicles, seeking new ways to apply technology in warfare. Today, the few surviving models in museums and private collections bear witness to a Germany obsessed with military innovation, where technical creativity combined with fanaticism and the urgency of total conflict, leaving a historical legacy that would influence the development of unmanned combat systems decades later. The Silbervogel supersonic rocket, the Nazi dream of bombing from space. The Silbervogel, known as the Silver Bird, was one of Nazi Germany's most visionary and extreme projects during World War II, intended to redefine the limits of aviation and strategic warfare. Conceived by Eugen Sänger and his collaborator Irene Brett, this hypersonic vehicle was designed as a suborbital bomber capable of crossing entire continents, delivering explosive payloads to distant targets without relying on Luftwaffe cover. The idea of a rocket that could bounce off the stratosphere combined advanced aerodynamic principles with high-speed physics, creating a project that seemed straight out of science fiction. The Silbervogel was to be launched from a gigantic acceleration rail using liquid and solid fuel rockets. Once in the stratosphere, the spacecraft would use atmospheric friction and density to bounce several times, maintaining hypersonic speed for hundreds of kilometers. The design featured an aerodynamic fuselage with a heat shield capable of withstanding extreme temperatures during re-entry, a challenge that German engineers attempted to overcome using the most advanced materials of the time. Its theoretical autonomy would have allowed it to attack targets as far away as New York from bases in Europe, making it a weapon of global terror. Although the project never progressed beyond the drawing board and experimental models, the Silbervogel had a significant influence on subsequent missile engineering and spaceflight. Sänger and Brett's studies were analyzed by the Allies after the war, inspiring long-range missile programs and, decades later, suborbital spaceflight and hypersonic vehicles. The project, though unfinished, demonstrated how Nazi Germany combined technological ambition with the desperation of the war's final years, seeking weapons that could change the course of the conflict through extreme innovation. Today, the Silbervogel symbolizes the audacity and delusion of Nazi engineering, a blend of advanced science, fanaticism, and war fantasy. Although it never materialized, its technical and conceptual legacy set a precedent in the history of aviation and rocketry, anticipating developments that would become reality decades later. It also represents the Third Reich's obsession with creating weapons that were not only deadly, but almost impossible to hit, a reflection of the extreme to which German engineering went in a context of total war and strategic desperation. The wind cannon, the sound weapon that promised to destroy with compressed air. The wind cannon was one of the most unusual and ambitious inventions developed by Nazi Germany during World War II, reflecting the regime's obsession with technological experimentation and the search for weapons that could generate an immediate psychological and military effect. The idea arose in a context of increasing pressure on Germany, when the Allies dominated the skies and engineers were looking for alternatives to conventional anti-aircraft artillery. The goal was simple in theory: to shoot down enemy aircraft using a concentrated flow of air without the need for projectiles, missiles, or bombs, an idea that defied the limits of applied physics at the time. The conceptual design of the wind cannon consisted of a large cannon or tube capable of expelling compressed air at extraordinary speeds, generating what engineers envisioned as an invisible projectile of air capable of destabilizing or destroying low and medium-altitude aircraft. Various methods of concentrating and directing the airflow were studied, including compression chambers and special nozzles to increase the speed of the expelled air. The project's ambition was such that some documents indicate initial calculations estimated speeds of several hundred kilometers per hour to achieve destructive effects on aircraft. However, experimental tests quickly revealed the limitations of the available technology. Generating an airflow with sufficient density and pressure to damage an aircraft proved virtually impossible, and the costs of constructing and maintaining the cannon were prohibitive. Furthermore, the logistics of installing such a large weapon and keeping it operational on the front lines rendered the project unfeasible, especially given the resource scarcity of the later years of the war and the priority given to other developments such as the V-2 rockets and jet aircraft. Although it never entered production and did not significantly affect Allied operations, the wind cannon became a symbol of the extreme and sometimes absurd creativity of Nazi engineering. It represents the desperate search for quick and spectacular solutions in a context of imminent defeat, where technological ambition was intertwined with scientific fantasy. Today, the project is remembered not only as a failed experiment, but as an example of how far the Third Reich's obsession with war ingenuity went, leaving a historical legacy of ideas as bold as they were impossible to realize. Genetic and medical experiments. Science in the service of horror. During World War II, Nazi Germany took medical and genetic experimentation to levels that are incomprehensible today due to their cruelty and lack of ethics. These studies were not aimed at humanitarian scientific advancement, but rather at the direct application of racial and eugenic theories to justify Aryan supremacy and the extermination of those considered inferior. Concentration camps became human laboratories, where millions of prisoners were forced into experiments that often resulted in permanent mutilation, extreme suffering, or death. Among the most notorious experiments were those conducted by doctors like Josef Mengele at Auschwitz, who investigated the effects of genetics on twins, intending to discover methods for propagating desirable characteristics within the German population. Atrocious procedures were performed. Injections of unknown substances, blood transfusions between twins, amputations without anesthesia, and studies of organ and tumor growth. All these experiments were carried out without consent, with complete disregard for human life, and many prisoners died as a direct result of these tests or suffered lifelong physical and psychological consequences. Other experiments included cold resistance tests, where subjects were submerged in ice water or exposed to extreme temperatures to study hypothermia in the hope of improving soldiers' survival in Arctic or high-altitude conditions. Research was also conducted on atmospheric pressure and high-altitude flights, using decompression chambers that caused the death of those who could not withstand the tests. Studies were also carried out with infectious diseases, experimental drugs, and toxic chemicals, exposing prisoners to deliberate infections to observe disease progression or the effectiveness of purported treatments. The purpose of these experiments was closely tied to Nazi ideology, to justify extermination policies, create chemical and biological weapons, and refine applied eugenics. The Nazi medical organization operated laboratories in several concentration camps, including Dachau, Sachsenhausen, and Ravensbrück, where human experimentation was systematically conducted with bureaucratic precision, as if the subjects were mere objects of study. The meticulously documented reports were used by some scientists to fuel theories of racial improvement and to serve military programs. After the liberation of the camps, the world learned the full extent of these atrocities. The Nuremberg trials for doctors revealed the scale of the crimes and established legal precedents, such as the Nuremberg Code, to prohibit medical experimentation without consent and to protect human rights. However, the scars of the survivors and the documentation of the experiments remain a chilling reminder of the depths of cruelty that can occur when science is used as a tool of power and oppression, and of the importance of maintaining a medical ethic that will never allow such horrors to be repeated. The Optical Invisibility Project, the desire to disappear before the enemy. During World War II, Nazi Germany undertook engineering projects that bordered on science fiction, including the development of optical invisibility technologies. The goal of these experiments was to make aircraft, vehicles, and even military installations virtually undetectable to both the human eye and enemy radar, granting an unprecedented strategic advantage on the battlefield. Nazi scientists combined advanced camouflage theories with reflective materials, mirrored surfaces, and lighting systems designed to confuse visual perception, seeking to literally erase objects from the enemy's view. The concept was applied at multiple scales. Small-scale models were built for testing in laboratories and wind tunnels, where researchers studied how light reflected or scattered off different surfaces. Some designs included movable panels and layers of materials with refractive properties that could adapt to ambient light, while others explored synchronizing artificial lights to create a temporary invisibility effect. All of this required not only advanced knowledge of optics and physics, but also a vast amount of resources, from special alloys to power systems that could supply the lighting and control devices. Although the results never achieved complete invisibility, the research demonstrated the extent to which the Nazi obsession with technological superiority led them to explore uncharted territories. The projects were extremely expensive and complex, and many remained unfinished due to material shortages, the advance of the Allied forces, and the regime's constant pressure for rapid results that could turn the tide of the war. Furthermore, much of the documentation was intentionally destroyed or lost during bombing raids, making it difficult to ascertain the true scope of the experiments. Today, the Nazi optical invisibility program is remembered as an example of the extreme audacity and technological ambition of a regime that sought to dominate through scientific means. Beyond its practical failure, it reveals the mindset of the Third Reich, a focus on limitless innovation, where advanced engineering was placed at the service of total war at enormous human and material costs. The concepts explored during these experiments, although they never materialized into effective weapons, laid theoretical groundwork that would influence the subsequent development of camouflage, invisibility, and electronic warfare technologies in later decades, demonstrating how desperation and obsession can drive scientific creativity even in morally reprehensible contexts. The Giant Train, the armored locomotive of the Empire. The German Giant Train project, conceived during the final years of World War II, was not only a demonstration of technical ingenuity, but also a reflection of the Third Reich's megalomaniacal mindset. The idea was to build a railway vehicle of colossal dimensions, capable of transporting not only troops and supplies, but also heavy artillery, light tanks, and large missiles, allowing for the rapid and secure deployment of military resources into hostile territory. This train was intended to function as a mobile and secure transport system, capable of withstanding the threat of aerial bombardment thanks to its armor and the robustness of its carriages. The design presented numerous engineering challenges. The locomotives needed to pull such a mechanical behemoth required immense power, while the reinforced carriages needed to support tons of weight without compromising the overall stability. Advanced suspension and braking systems were considered, as well as technologies for distributing the weight over special tracks that could withstand the stress. Even secret compartments were envisioned to conceal strategic weaponry, transforming the train into a kind of mobile fortress capable of functioning as a barracks, depot, and artillery battery on rails. Although prototypes were built and conceptual tests were conducted, the giant train never reached the production phase. Material shortages, the constant pressure of the conflict, and the progressive disintegration of German industry made it impossible to carry out a project of such magnitude. Even so, the existing plans and models demonstrate the technological ambition of the Nazi engineers and their willingness to explore ideas that pushed the boundaries of practical engineering, showcasing a level of creativity and audacity rarely seen, albeit driven by fanatical and warlike motives. Today, the giant Nazi train is considered one of the most extravagant and visionary projects of the Third Reich. Although it never materialized, it represents the extreme combination of technological innovation, an obsession with power, and a desire for absolute control. Studying it not only allows us to admire the audacity of the engineers of the time, but also to reflect on how war and fanaticism can push engineering toward concepts that, under normal circumstances, would have remained solely in the realm of imagination or science fiction. This colossal train remains a testament to the reach of human creativity when fueled by ambition and the urgency of war. The Nazi Atomic Energy Program. Nazi Germany's atomic energy program was undoubtedly one of the most audacious and secretive endeavors undertaken during World War II. From the early years of the conflict, Hitler and his scientific advisors recognized the destructive potential of nuclear fission and saw in it an opportunity to develop a weapon capable of altering the balance of power in Europe and the world. To this end, they recruited leading physicists and chemists such as Werner Heisenberg, Otto Hahn, and Carl Friedrich von Weizsäcker, many of whom were already internationally renowned for their contributions to quantum physics and nuclear chemistry. These scientists worked in hidden laboratories, primarily in underground facilities and isolated research centers, to protect strategic knowledge and materials from Allied espionage and internal sabotage. The program encompassed multiple lines of research. On one hand, it aimed to construct experimental nuclear reactors capable of sustaining controlled fission reactions, which required a complete mastery of uranium geometry, neutron moderation, and the handling of highly radioactive materials. On the other hand, it studied uranium enrichment and the production of heavy water, essential for slowing neutrons and sustaining chain reactions. Simultaneously, theoretical designs for nuclear weapons were being developed, precisely calculating the amount of material needed, the type of detonating explosive, and the resulting energy release. Each experiment was extremely complex and conducted under absolute secrecy, reflecting the Nazi obsession with maintaining absolute control over scientific advancements and any information that might leak to the Allies. However, the program faced numerous obstacles. The lack of strategic resources such as high-purity uranium and sufficient quantities of heavy water severely limited experimental progress. Furthermore, the war forced the prioritization of projects with immediate results, such as the mass production of VIII rockets, jet aircraft, and conventional weapons. The exodus of scientists and the psychological pressure of working under a totalitarian regime also affected the program's productivity and coordination. As a result, although theoretical calculations and initial experiments were promising, neither a functional reactor capable of sustaining a continuous nuclear reaction nor an operational atomic weapon suitable for battlefield use was ever built. The legacy of the Nazi nuclear program is complex. On the one hand, it demonstrates the Third Reich's capacity to channel scientific and technological resources into enormous projects, even in the midst of war. On the other, it reveals the risks of science placed at the service of ideology and extreme military ambition. Nazi Germany was, in theory, relatively close to understanding the fundamental principles of nuclear energy, but it never managed to translate that knowledge into a real weapon. Today, the surviving documents, plans, and experiments serve as a historical cautionary tale. The combination of scientific genius with political fanaticism can lead to inventions of devastating potential, but it also shows how a lack of strategic planning and human error can prevent even the most ambitious projects from coming to fruition.